So this is the second video dealing with inheritance and polymorphism. We're breaking up these videos into multiple parts, mainly to make it easier to watch because attention spans probably 15 minutes max. I think the rule of thumb for these videos is about 1 minute per grade level. And you guys are in college, so I guess that means whatever I want. But I'm trying for 15 minutes because that's, I feel like, a pretty good thing. 15 minutes max. These videos will probably be smaller. So all right, now we can actually get into reviewing the actual inheritance. So we're going to create a reptile, and reptiles, as you know, are animals. Assuming I can spell reptile correctly. Reptile. Let's see. So, reptile, public class reptile. Reptiles are animals, right? In the real world, a reptile is a type of animal, and we want to model this, right? We're trying to model this as much as we can to the real world to make it pretty relatable. So to do that, we say a reptile is an animal. A reptile is a type of animal. We put extends animal, and this means that a reptile can do all the things that a animal can do, and a reptile has all the things that an animal has. Okay, doesn't get everything from its parent. It doesn't. It gets the instance variables, all the things that its parent has. And it gets all of its instance methods, all the things that its parent can do. But it does not get its parent's constructors, which is going to lead us into this interesting headache that you're not really ever going to have to worry about, but it's useful to know. Okay, so we get the variables, we get the methods from our parents. Okay, you can only put one class there. We'll go into that later, but you can't extend multiple classes. If you don't extend a class, guess what? You're extending a class. If you don't put down an extends, if you don't inherit from somebody, you have an implicit extends object over here, which extends the object class, and that's how Java ensures that everything is literally an object. So if you follow the chain of logic, a reptile is an animal, and an animal is an object, so that means that a reptile is an object, right? But remember, it's got that kind of logic, that grade school logic in there. All reptiles are objects and all reptiles are animals, but not all animals are reptiles, and not all objects are going to be reptiles either, right? So that will come in handy when we mess with polymorphism, rather than using things named foos and bars and bosses, right? We're going to use reptiles and animals to make sure that concept gets hammered in. So public class reptile extends animal, okay? So this means that a reptile has everything that a animal has, except for the constructors. But I get a constructor for free, right? So let's go ahead and build a reptile and start messing with it and seeing what we can do with it. So reptile r is equal to a new reptile. Okay, and like I said, so I get a default constructor. I don't get my parent's constructor though, which allows me to, so I don't have a constructor to build with. But I do get my parents' move method, and I get my parents' eat method. Right, my parent object, also known as the superclass, right? Reptile superclass is animal, animal superclass is object. So, but I like thinking of it as the parent-child relationship, mainly because parent is 2 syllables and superclass is 3, and longer to spell. So our eat thing. Let's go with something tasty. Now, last time we ran it and we didn't have anything set up in the constructor, we got a null. But something interesting happens this time. I run this, and I get Andrew moves normally. Andrew eats something tasty generically. That's pretty cool. All right. So, this is Andrew, though. Now, am I wrong? Right? Am I wrong? I said that you don't get your parent's constructor, but here I am clearly getting Andrew, which is the default animal thing. All right, well, okay, maybe the instructor's wrong, but there's a way to test that, which is to put in a public reptile constructor here and just create it blank, right? This is what Java provides by default. So let's go ahead and run it now. And we are going to get the same exact thing, right? Bar at the bottom, reset. Andrew moves normally. Andrew eats something tasty generically. So, something interesting is happening here. Something is weird. Java's doing stuff again that we didn't tell it to do. Java loves to do stuff that we didn't tell it to do all the time. And this time, in constructors, it has a line at the very beginning. There's an implicit call to super. What the heck is super? Well, remember, I said that your parent is your superclass, and super is short for superclass. Now, what this does, remember, we had a method called this, which would call another constructor with, we didn't have a method. We had a keyword called this, which would call all the other we could use it to call constructors. Well, super with no followed by empty parentheses calls my parent's method without any parameters. Okay, every constructor has this. Okay, every constructor has that call implicitly. So what happens here? Super calls animals constructor, and animals constructor calls animals other constructor and says, hey, take this string as the name and store it in the instance variable called name. Right? So Reptile implicitly calls this constructor, and this constructor calls this one, right? Which provides this. So we go from reptile to animal with passing in a string. Okay, that's pretty cool. So we are leveraging our parents, our parents constructor, right? And we'll kind of show that off a bit more. There's a lot of interesting directions I can take this, but let's go ahead and just clarify. I did mention that basically this is implicit. This is an implicit call that every single method has. Okay? So let's go ahead and show you how implicit it is. If I delete this default constructor over here, I get an error because there's no default constructor, because I'm going to be calling, the assumption is my parent has a default constructor I can call. Right? So this doesn't come up much, but essentially there is a chain of supercalls, and it's assuming I can call my parent's default constructor, which is the constructor that takes no parameters. And if it doesn't exist, then that's an issue. The other thing is that means there's a implicit supercall right here. So the first thing Reptile does is it calls its parent's constructor, and super calls its constructor. Calls its parent's constructor. What's animal's parent? It is object, so it calls object's constructor. So it calls all the things to build an object. That's useful. So it does chain up all the way. This is actually called constructor chaining. Learned that like 5 minutes ago. So the end result is to keep in mind that we can call our parent's constructor. Okay. So, okay. Now that isn't going to come up too often because we're actually going to probably, completely overwrite what we do for our parents. So what we're going to do is we are going to go ahead. Oh, and let's go ahead and just prove that once and for all that this gets called. Right? Ding, right? The constructor got called. Okay, so you might be wondering where that's going to come up. Is it going to come on the test? No. You'll probably see it as one question on a quiz, and you'll never see it again. A throwaway point on a quiz, but you're probably not going to see it again. And it's probably not going to be. It's going to be basic. Okay, so basically the key factor, remember, is that every constructor has an implicit call to its parent's default constructor. Okay, so let's go ahead and make our own constructor then. Rather than the animal, Andrew, that kind of goes together. So let's make a reptile called Ralph. So let's go ahead and set its. If we don't provide it, we'll go this.name is equal to Ralph. Now I love working on this example because because in trying to fix things, we come up with new issues, right? I don't want it to be Andrew. I want it to be Ralph, but now I've got an error here. It says the error says name has private access in inheritance.animal. saying that that name is a private variable, so I can't access it. And that's true. Remember, public means everybody can see it. Everybody in the package, everybody in the world, everybody can see it. Private means nobody can see it. It's just me. Just me. It's private to me. So the animal class has access to the name. So we need some kind of like between access, like something that that I can see it, my children can see it, and that's protected. Now, protected allows three classes of classes to access this. Three types of classes. I can access this, right? So it's kind of like private in that I can access it, but it limits other people who are able to access it. My subclasses can access it, so notice that removed our error. So protected is kind of like private, but it also allows my children to access this variable. In addition, it also allows anybody in the package to access it. So playpen, right, can now access r.name. So everybody now in the package and in the and that's a subclass of mine. Doesn't have to be in the same package, but everybody who's a child can now access that. Okay. So big change. So really, that was a whole lot to just change one keyword and just make a constructor, right? So now we run this. Ralph moves normally. Ralph eats something tasty generically, right? And here's the relevant bit for the super keyword at this URL, right? So, and this is and these are the relevant things here. Okay, so I think I'll create another video to start off with doing overwriting.